Before you even see, your body feels it. The air changes, becoming thinner, colder, more honest. Each breath arrives like a gentle warning. This is no ordinary place. You are over 4,500 meters above sea level, and the planet has decided to test everything you thought you knew about existence. The cold doesn't come from the wind. The cold comes from the ground, from the rocks, from the sky that is too close. It is a merciless light that illuminates everything without warming it. The shadows are blue, the mountains white, and the horizon seems to be on another planet, because, in a way, it is. Tibet is not simply a geographical location, it is an anomaly on the planet's surface, with an average altitude of 4,500 meters, surrounded by the highest peaks in the world, isolated by mountain ranges that border habitable space. Here, the atmosphere is different, the oxygen is different, the experience of existing is different. Welcome to Remote Planet. If you seek to explore our planet to its limits, join us on this expedition by subscribing to the channel. Today we're going to descend into the heart of the Tibetan Plateau, the roof of the world, the cradle of Asia's great rivers, the place where humanity learned to survive, where no other civilization would have even attempted. This isn't a tourist trip. It's an exploration of the planet at its very limits. But to understand why this place exists, we first have to go back in time. 45 million years. It all began with a collision. Approximately 45 million years ago, the Indian tectonic plate collided with the Eurasian plate in what geologists describe as one of the most violent and long-lasting continental collisions in the planet's history. Two landmasses moving at the speed of fingernails, growing centimeters per year, accumulated such monstrous energy that the result was literally planetary. The Earth's crust didn't give way downward, it gave way upward. And the collision isn't over. India is still pushing against Asia, the Himalayas are still growing, and all that geological power has a destiny. All that ice, all that snow, all that elevation eventually becomes something that sustains almost half of humanity. There's a name for Tibet that few in the West know, but that resonates deeply in Asia: the third pole. The first is the Arctic, the second Antarctica, and the third, Tibet, because on this plateau lies the greatest concentration of glaciers outside the poles. More than 46,000 glaciers cover its mountains, a system of frozen freshwater reserves unparalleled in the planet's temperate zone. When that ice melts, and it melts constantly with the seasons, with the years, with the centuries, the water isn't lost, it becomes rivers. Rivers that aren't mere streams of water, but arteries of civilization. From Tibet spring the Ganges and the Brahmaputra, which irrigate India and Bangladesh, the Mekong, which flows through Indochina, the Yangtze and the Yellow River, the two mother rivers of China, the Irrawaddy of Myanmar, and the Indus, which gave its name to an entire civilization. Nearly 2 billion people depend on the water that falls as snow on Tibet. It freezes in its glaciers and melts in its rivers throughout the year. 2 billion, almost a quarter of humanity. And here, modern science issues a warning that the atmosphere of Tibet is already proclaiming. Tibetan glaciers are retreating, not equally everywhere, not at the same rate, but the trend is clear and verifiable. The third pole is melting. In some regions, glaciers have lost between 10 and 15% of their mass in recent decades. This is a question that the 21st century will have to answer urgently. But before thinking about the future, there's a present to experience. Because Tibet's climate waits for no one, forgives no one, and is unlike anything you've ever known. A single day in Tibet can encompass every climate on the planet. The sun rises brightly at 7 a.m., and the temperature climbs with deceptive speed. By midday, the solar radiation at this altitude is so intense that the skin feels like a metallic burn. The thin atmosphere barely filters out ultraviolet rays. The light bounces off the land, and glaciers are exposed from every angle. And yet, at 3 p.m., a storm can descend from the west without warning, bringing snow, hail, and winds exceeding 100 kilometers per hour. Daily extremes that in lower areas would be seasonal extremes. Summer temperatures can reach 20 degrees Celsius at midday and plummet to negative 10 degrees Celsius the same night. In winter, western Tibet can experience temperatures of negative 40 degrees Celsius, with winds that amplify the perceived cold to levels that no technical equipment recommends facing. The monsoons reach eastern Tibet, where the terrain breaks into deep canyons and mysterious forests, but most of the central plateau is semi-arid. It's not that it doesn't rain, it's that the cold evaporates the moisture before the soil can absorb it. Tibet is both a desert and a water reservoir, a water contradiction that only the physics of altitude can explain. And yet, nature found ways. The wind doesn't just erode, it also carries seeds. The cracks in the rocks accumulate soil. In the warmer months, the plateau is covered in a short, resilient grass that seems miraculous. Yellow, violet, and red flowers appear briefly, as if the landscape wanted to demonstrate that life doesn't ask for permission, only opportunity. But nothing in this landscape is as extraordinary as what happened when human beings decided that this would not simply be a place to pass through, but their home. When you arrive in Tibet, your body panics. At 4,500 meters, the air contains 40% less oxygen than at sea level. Your lungs work twice as hard to extract what your body needs. Your heart races, your head aches, and you may experience nausea, confusion, and profound fatigue. It takes the body between 1 and 3 weeks to begin to partially adapt, producing more red blood cells and altering blood chemistry. And even then, many people never fully adapt. Tibetans have been here for 50,000 to 60,000 years. This is not a metaphor, not an exaggeration. Genomic science has shown that populations inhabiting the high plateau for tens of thousands of years developed biological adaptations that no other human group possesses to the same degree. Thanks to variations in the PAS1 gene, Tibetans maintain hemoglobin levels similar to those of people at lower altitudes. Their bodies do not accumulate more red blood cells. Instead, their lungs and tissues are more efficient at absorbing and utilizing available oxygen. It is a sophisticated biological solution that took tens of thousands of years of evolution to develop. Part of that gene, according to geneticists, was inherited from the Denisovans, an archaic human species that inhabited Asia hundreds of thousands of years ago and with whom the ancestors of Tibetans coexisted. Tibet is, among other things, a place where the evolutionary history of humanity is literally inscribed on the bodies of its inhabitants. And what that adapted body has built over millennia is one of the most complete and self-sufficient cultures the planet has produced. The nomads of the high plateau know the terrain with a precision no GPS can replicate. They know when the snow will arrive. They know where the soil retains moisture for the plants in August. They know which paths disappear with the thaw and which remain year-round. The yak is not just a domestic animal. It is an entire economy. Its wool, its milk, its butter, its meat, its leather, its dried dung for firewood. Every part of the animal has a use. In Tibet, the yak is what the buffalo was to the Great Plains of North America, the material foundation of an entire civilization. But the people of Tibet did not only learn to survive here, they learned something far more difficult, to find beauty in harshness. And that quest led them to build something that still takes your breath away after 1,000 years. Life on the Tibetan plateau is both scarce and extraordinary. There is no abundance here, no jungles or tropical biodiversity, but what does exist has achieved forms of adaptation that biology still studies with amazement. The snow leopard, Panthera uncia, is perhaps the most perfect symbol of this balance. A feline built for invisibility in landscapes of rock and snow, with broad paws that function like natural snowshoes on the snow, and an extraordinarily long tail that serves as a counterbalance when climbing vertical cliffs and as a scarf when sleeping wrapped up in the cold. Seeing a snow leopard in the wild is so unlikely that many naturalists spend decades searching for it without success. It's not exactly shy, it's geological. It moves with the patience of the mountains. The Himalayan blue sheep, Casa virales, move with a precision that allows no room for failure, because on this high plateau, every missed landing has an energy cost that the body cannot easily afford. The eagle rides thermals across the plateau with an efficiency that modern aeronautical engineers have studied. The fish of Lake Namso, at over 4,700 meters, are one of the few freshwater fish species that survive in such low oxygen levels. Every species that exists here is the correct answer to a question posed by the environment, a question that took millions of years to answer. And in that environment where only the essential survives, human beings chose to build the tallest temples on Earth, not to survive, but to transcend. There is a question that this landscape inevitably provokes. When the body is at the limit of its capacity, when the air is so scarce that breathing becomes a conscious act, when the horizon is 1,000 kilometers of mountains and the sky is closer than any city, what remains of the ordinary? What remains of the mundane? The Tibetans answered that question with centuries of practice and architecture. Buddhism arrived in Tibet in the 7th century CE, brought from India during the reign of King Songtsen Gampo. It found fertile ground, a culture already deeply connected to natural rhythms, to contemplation, to death as part of the cycle. The result was not a replacement, but a synthesis. The Tibetan monastery is not just a place of worship, it is a university, a hospital, a center for cultural preservation, an observatory of inner experience. In its most recognizable architectural form, it clings to the rock as if it had grown there, sometimes indistinguishable from the crag that supports it. The colors white, red, and golden ochre are also the colors of the landscape. The Potala Palace, built at over 3,600 meters, is perhaps the most impressive sacred building that humanity has produced in terms of its integration with the natural environment. 13 stories, more than 1,000 rooms, a library with texts dating back to the 16th century, a city within a palace, inside an artificial mountain built by human hands. But the true heart of Tibetan spirituality is not in the buildings, it is in the practice. Meditation in Tibet is not a relaxing activity or a stress management technique. It is a systematic and rigorous exploration of the nature of consciousness. The great masters of Tibet, the lamas, dedicated decades to exploring states of consciousness that modern neuroscience is only now beginning to describe. Studies with experienced Tibetan meditators have shown patterns of brain activity during deep meditation that are not observed in other states. High-amplitude gamma waves, synchronization between normally disconnected brain regions, and a neuronal cohesion that researchers describe with words suspiciously similar to what Tibetan masters have been asserting for centuries, that the mind can be trained to perceive in ways that ordinary thought does not contemplate. And yet, there are phenomena in Tibet that even the most advanced science regards with a mixture of fascination and bewilderment. Things that the high plateau does not do and that no other region on the planet replicates in the same way. Tibet is home to some of the most enigmatic high-altitude lakes on the planet. Namso, at 4,700 meters, is one of the highest salt lakes in the world. Its waters change color depending on the time of day: turquoise at dawn, deep blue at midday, almost black in storms. The reflection of the snow-capped mountains on its surface creates a symmetry that seems both edited and real. There are no cities on its banks, no noise, only water, wind, and the perfect geometry of the landscape. Farther south, the Yarlungpo Grand Canyon, the river that later becomes the Brahmaputra, is the deepest canyon on the planet. Reaching depths of 5,300 meters at its deepest points, it surpasses the Grand Canyon of the Colorado in scale. Inside, the river plunges in waterfalls that have not been fully mapped. There is a section of the canyon known to explorers as the Great Bend, where the river turns 90 degrees and the vegetation changes from alpine to subtropical in matter of kilometers. It is as if the planet has compressed 3 different climate zones into a single slice of rock. At extreme altitudes in western Tibet, travelers and pilots have consistently described an optical phenomenon known as Tibetan glory.
halos of light circling around the shadows cast by the sun on low-lying clouds, a phenomenon that physics explains through the diffraction of light in supercooled water droplets. But the scale and frequency with which it occurs here, combined with the atmospheric transparency at this altitude, creates visual spectacles that photographs rarely capture faithfully. Because these mountains, these rocks that today hold up the sky, were at the bottom of the Tethys Ocean 200 million years ago. Tibet is literally the oldest seabed uplifted to become the roof of the world. And that geological past, that present climate, that extraordinary biology, all have come to the attention of the most advanced science of the 21st century, with consequences that extend far beyond Tibet. In recent decades, Tibet has become one of the most important natural laboratories on the planet. Weather stations on the high plateau measure variables that exist nowhere else. The interaction between surface heat and the stratosphere at altitudes normally studied only by weather balloons. The warming of the Tibetan soil, occurring at roughly twice the global average rate, is creating a heat pump that is disrupting the patterns of the Indian monsoon and the polar jet stream, consequences that climatologists are beginning to model more accurately. Ice cores extracted from Tibetan glaciers are chronicles of the planet's climate. Each ice layer represents a year. Each bubble trapped in the ice is a sample of the air the planet breathed at that time, stretching back thousands of years. Researchers can read temperature fluctuations, volcanic events, and solar cycles and compare that past with the present to understand the speed and direction of current change. They have spent decades climbing Tibetan glaciers to over 6,000 meters to extract these cores before they melt. What they found confirmed what climate models suggested. The recent warming is unprecedented in at least 2,000 years of recorded Tibetan ice. But the science of Tibet is not just about climate. Tibet, which for centuries was almost inaccessible, is paradoxically becoming one of the most studied places on the planet. Not because the world has reached it, but because Tibet, through its climate, its rivers, its genetics, and its atmosphere, has always been reaching us. And perhaps that is the most extraordinary thing about this place. Not that it is extreme, but that being extreme, it is not alienating. Tibet has always been a part of us. There is a moment at sunset when the Tibetan plateau seems to stand still. The wind dies down, the clouds remain motionless, and the light, that impossible orange light that only exists at this altitude, turns into colorful mountains that no screen can faithfully reproduce. In that instant, the body forgets that it lacks oxygen, stops measuring the cold, and only perceives the scale. Tibet has been building itself for 45 million years. It was the bottom of the sea and became the roof of the world. It created rivers that give life to almost half of humanity. It harbored a culture that chose to call itself. Tibet is home to the most extreme place on Earth, and it has done so with an elegance that, even after millennia, remains difficult to explain. We are not strangers to this place. The water you drank today may contain molecules that passed through a Tibetan glacier. The monsoon that irrigates the fields that produce the rice on your table was partly shaped by the geometry of this plateau. The jet stream that defines the climate of the Northern Hemisphere has one of its invisible axes in Tibet. Tibet reminds us of something that cities tend to conceal, that we are organisms living on a living planet, that glaciers are not mere decoration, that oxygen, water, and temperature are not the backdrop of our existence, but its very conditions. The Tibetans understood this 50,000 years ago and built upon that understanding a culture where impermanence is not a tragedy, but a principle, where the mountain is not an obstacle, but a teacher, where silence is not absence, but density. Every expedition to a remote planet seeks that moment, when a place ceases to be a destination and becomes a perspective. Tibet doesn't provide answers, it provides scale. And scale, if you know how to look at it, transforms the questions. Now we want to know something. From what part of the planet are you watching this expedition? Write it in the comments. Every point on the map is part of this exploration.